Brad, thanks so much for joining us today.
It's great to be with you, Chris. Thank you.
Yeah, you too. So, for those who don't know, Brad, tell us a little bit about yourself and what Avadain is all about.
Absolutely. So my background is in technology commercialization. I've been doing that for more than 20 years, taking ideas from basically research institutions, helping develop them and bring them into the commercial markets. And in the course of that, in 2016, we came across this idea that some researchers had at the Fraunhofer Institute for Applied Solid-State Physics in Germany, that is to create the kind of graphene that companies would want to use as an additive material to make them lighter, stronger, more conductive, and so forth. Graphene, as you probably know, is the strongest material ever discovered. It's also the most conductive material ever discovered. The problem is making it in a way that industry can use it. So we began backing this in 2016. In 2017, Panasonic co-invested with us, and we've been partners in this ever since. We formed Avadain in 2022 specifically to bring forward this technology, and it's really worked well. We're well on the way to scaling, and very excited about the progress.
Well, I think you give us all too much credit for, most of us who don't live graphene day in and day out. I don't think many of us do know too much about it. Tell us a little bit about the material, what makes it so conductive, what makes it so strong.
So graphene is a single atomic layer of graphite. Now, everybody knows graphite. It's very boring. It's pencil lead. It's used in other applications. But when you reduce it to, say, less than 5 atomic layers, it takes on absolutely miraculous qualities. It has a free electron on it. So each atom of graphene has a free electron. So what that means is that it's able to conduct electricity really almost at the speed of light. And it doesn't have resistance, unlike copper, for example, where the more electricity you push through copper, the hotter it gets. And if anyone wants to test that, just put your hand on an electric coil on a lawnmower. Graphene doesn't have that. It functions in a completely new way to conduct electricity. The electrons move without resistance. And each graphene molecule has 6 sides, and 3 are bonded to each of the other atoms in the graphene lattice work. And what that means is that it's got a very, very tight atomic bond. So although it's flexible and bendable, you can use it for foldable electronics, the fact is that it's 200 times stronger than steel. So if you were to use graphene in applications like ballistic armor, you could make that body armor lighter, more flexible, and yet impenetrable to bullets. And so graphene has great promise as a material. It won the 2 researchers who discovered it in 2004 the Nobel Prize in Physics in 2010.
Now, why hasn't anyone put it into commercial application yet, and how are you solving for that?
So when we first spoke, there were very, very few companies that put graphene into applications. Now I would say there's probably 2 or 3 per day that are doing it around the world. We're in the middle of the graphene revolution. The demand for graphene is exploding. But there are different grades of graphene, starting with graphene oxide, which the communist Chinese, have really pioneered in industrial applications. The Chinese are putting into just about everything they can think of, but that's a very low quality form of graphene. It's also very inexpensive to make. Then there are intermediate grades of graphene. The grade of graphene that we are focused on is large, thin, and defect-free. We call that LTDF graphene. That's the highest quality of graphene because it has a very large surface area. It's 5 or fewer atomic layers thick, and it's without defects. So that's the premium quality of graphene. So graphene is being used really in hundreds of products, and by the end of this decade, I think you'll see it in tens of thousands of products. So it is a material that is really redefining manufacturing today.
So where are you in terms of commercializing this business and in terms of kind of having the technology ready to go to start applying and putting into products?
Sure. We are the only graphene company to employ a licensing model. And the reason is that we want to focus our energy on developing and optimizing the technology. We are licensing our technology to chemical companies and advanced materials manufacturers. These are companies that have a lot of experience in making new materials. They also have the plant, people, and equipment to manufacture that material, and they also have the sales and marketing for the distribution of the material. Our first licensee is Harcross Chemicals. We entered into a license agreement with them last December. We're building the first pilot plant for them to demonstrate that what we've achieved in the lab, we've scaled the production 2,000 times, that works in the field in a manufacturing environment. We'll be shipping that plant to Harcross in September. Once they vet that, then the plan is for them to order additional production capacity. At the same time, we will then be taking other potential licensees for manufacturing graphene to Harcross at their headquarters in Kansas City, Kansas, to see the production in place and to then enter into license agreements with additional companies. Our goal is to have 10 licensed manufacturers by 2028.
Help us understand what a license contract looks like, both in terms of scope of work, what do you do versus not do in those situations, and then in terms of what it could look like from a monetization perspective.
Sure. So as the licensor rather, our responsibility is to give a technology that is ready to go for the manufacturer. We are doing all of the work that's required to get that process to be as efficient as we can make it, as economical as we can make it, and as modular as we can make it so that we can scale it very easily over time by adding additional modules to that. Very proud to say that the team has come up with a modular reactor, which is the heart of the production. It's a great reactor. It's ready to go, and we're super excited about that. We then through the license agreement, we give the right to the manufacturer to use our technology in their facility to manufacture as much graphene as they need to serve their existing and new customers. So what the agreement looks like is we have a minimum of 2 metric tons per year. We get a 10% royalty from the manufacturer, which is very fair. We're looking at getting at least $200 million in annual recurring revenue in 2028 through our manufacturing licensees.
And to help us, get a better sense of what all this looks like, how do you create graphene? What's involved in that process?
So we start with the feedstock, which is graphite. And think of graphite as millions of layers of graphene bound together tightly by atomic forces called van der Waals forces. And over millennia, the van der Waals forces take this graphene, which is carbon, and brings it together very tightly, and it continues to compress. Not as tightly as, say, diamond, which is another form of carbon, but still very tightly. What we do then with our technology is we have created a very unique method of exfoliating, meaning separating the atomic layers of the graphite. That's really how we manufacture graphene. We put the graphite into the reactor. It undergoes an electrochemical process that separates gently the layers of graphite so that what we have at the end of the process is graphene. The increase in volume, once you overcome these van der Waals forces, the attractive forces that bind the graphite together, is unbelievable. Think of maybe a 3-kilogram lump of graphite would fill a 40-foot shipping container once you separate the atomic layers. That's not only because graphene has such a large surface area, but that the bonding of the graphene to form the graphite is very, very tight. But once you overcome that, the material is extremely light. And it's that material which you'll need only a tiny, tiny amount of to make a huge difference in products.
In terms of commercializing this, how are you going to market? How did you win your first client? And what is it going to take to get to 10 in the next 3 years?
Well, we're lucky in that demand for our graphene exceeds supply, and it's likely to do so. When we talk about 2 metric tons for a production facility, that has to be measured against the Graphene Council's projection of 30,000 to 90,000 metric tons of demand between 2030 and 2035. So we have a market that needs to be addressed. We believe we have the only technology that's able to address that market. That's for the premium end of the market, say 10%. 90% is already being saturated by other materials of varying qualities of graphene. And so it's not so much having to push a strategy and convince manufacturers to take it. Rather, it's a pull strategy whereby we're demonstrating that our graphene can meet this market demand. So, we have a fabulous first licensing partner in Harcross Chemicals. They're really great to work with, really great people. So we're spending a lot of time working out the bugs in the manufacturing process, because it's always challenging to go from the laboratory into industrial production. There's no doubt about that. But Harcross is in there rolling up their sleeves with us to solve those problems. So getting additional licensees, I personally don't believe is going to be the issue because of the number of companies that have expressed an interest in doing it. It's really demonstrating that our process works as advertised.
In terms of Harcross, I'm just curious, what types of products do they make, why are they licensing it? What is it going to be used for?
So Harcross is in the business of making specialty chemicals for a wide variety of companies. And so they see graphene, the electrochemical process for manufacturing graphene, producing a specialty material that can either augment the specialty chemicals that they make for different applications, or offering it to new clients for yet other applications. So they fit right into the market for what we're doing.
You're doing a raise right now in net capital. What will the use of funds be?
So the raise on net capital is going, as you probably know, extremely well. We did $1.25 million in the first 24 hours.
Congrats.
Well, thank you. We're very, very fortunate. And really what it is to support, the funds will be used principally for the support of building the pilot plant and deploying that and continuing to build our IP portfolio. We have patents granted in 48 countries right now. We have lots more patents pending. Those are the 2 big uses for the capital. Understood.
When you think about what success looks like, let's talk about it just in 2025, because there's so much going on. What does that look like? Are you ramped up and fully manufacturing at scale with your first partner?
I think what we would say is that we've validated the process, the manufacturing process in the industrial environment. I think that will be the major milestone for 2025. And the other will be that Harcross begins getting orders for the graphene. So as they continue to invest in new plant and adding capacity, they have customers who they will be selling to. I think those are the two big takeaways for 2025.
That's really interesting. In terms of exit potential, I mean, I could think of any number of chemical companies or, material companies that would want something like this, whether it's, Dow Industrial or any of the others. How do you think about an exit for a business like this?
It should be an acquisition. Wall Street punishes licensing companies by the way they value them. So that doesn't make any sense for us. I'm not ruling it out 100%, but it would not be one of the top choices. We see three potential categories of companies: chemical companies, advanced materials manufacturers, and tech companies. We think tech companies can then see the benefit of our quality of graphene for their products, and they would, I think, have an interest in preventing other competitors of theirs from gaining access to it. So I think there are really three categories of potential acquirers for us.
I'm going to give you the last word here. For those investors who are on the line, they're thinking about it, but they're not totally sold yet, what do you want them to know? What would you say?
Well, I would say that we've got a lot of momentum going with our company. We've got great partners. Panasonic, as I mentioned earlier, is our original co-investor, also the largest shareholder other than me. We have Harcross Chemicals, which is a great first manufacturer and validates the interest of manufacturing. I don't know if I mentioned it before, but Henry Ford III joined our board. He is the chairman of the board now, and he's providing great strategic guidance for us, very upbeat on our potential. And finally, I think we align with the Trump administration's key economic priorities. In the revitalization of manufacturing, Avadain can play a huge role in making products better and giving a leapfrog advantage to U.S. manufacturing to overcome the cost negatives associated with onshore manufacturing here. In terms of defense, both China and Europe have focused on trying to use graphene, even though it's suboptimal quality graphene in their defense sectors. We can provide that for the U.S. at a much higher quality level and therefore much more effective. In the energy sector, graphene has been shown to improve everything from electric vehicle batteries to energy storage to supercapacitors. It really can dramatically improve the performance of these products. And finally, in shipbuilding, graphene has been demonstrated to be used to provide state-of-the-art coating on the ships, which makes them less likely to get corrosion, but more importantly, they flow through the water more quickly. So I think that we are at the beginning of a new industrial revolution, not only because of the revitalization of America, but because we now have a material that can make a huge difference in the quality of manufactured products.